look like? I've lined it up so that I put the 4 possibilities of eggs along the top. I put the 4 possibilities of sperm along the bottom. I'm not going to draw the chromosome because I'm really only concerned with the letters on the alleles that were on the chromosomes within those eggs and sperm. So going back to the sperm, I saw that I had big A, little a, little a. So I'll do that. Over here, I'm not going to change letters anymore. Big A, I meant colors, little a, little a. If I look at the eggs, they were the same thing. Little a, big A, big A. The way that you fill it in a Punnett square is now I'm going to drop every letter for this egg. It goes into every row below. Anything on the left is going to slide to every column to the right. Keeping in mind that it's easier when I interpret it to keep all the capital letters first, so that you don't have somewhere have it has a recessive dominant and others have a dominant recessive. To keep this easy to follow, if it has a dominant A, I will put it first. And this one drops down to be a little a. Slides over. There's my big A. Bring down the recessive A. Big A slides over. A big A drops down. Big A slides all the way over. The big A drops down. So you can keep doing this. I know this is a dominant A, so really, whenever it happens, it's going to be first. So I can slide them all over. Now I bring down whatever is in the egg. Bring it down, bring it down, bring it down. So I'll do this quickly, keeping in mind, so this one had the dominant A, so I still keep it first. This one had the recessive A, so I don't always necessarily have to put the sperm's letter first. I like to keep it consistent. And the last one, alright, so now what this does is it sets up this Punnett square. It's a really big Punnett square. In probability language, there are 4 up here. 2 out of 4 is the same as what probability? Simplify down to 1 out of 2. Same thing over here. This is why if you do, this is what's called a monohybrid cross. You're looking at one gene. Mono means 1. You're crossing a 1 gene egg cell with a 1 gene to a sperm. To simplify this, what they do is they say, you know what, this was only caused by replication, that second egg. This little a only became because of replication. So your probabilities will never change. So what they do is they say, assume that replication really isn't taken into effect. So they will then do just the unique ones. So if there are 4 egg cells up here, it's 2 out of 4 are the little a, which reduced the probability. If I only had 2 eggs, it means 1 out of 2. So I'll put the recessive A in 1 out of the 2 that I do here. The same thing here, when there's 4, 2 out of the 4 are dominant A. If I reduce that to a fraction of something out of 2, then it's 1 out of 2 are dominant A. The sperm, I can bring down as well. There's 4 sperm, 2 have the dominant A, 2 have the recessive A. So it's 2 out of 4, or 1 out of 2. So I went the wrong direction. So there and there. So if I fill in this Punnett square, we now look at a ratio. And so we look at the genotypic ratio and the phenotypic ratio. A genotype is the letter combination. So right here I have 1 big A, that's what I have out of the 4. Then I have 2 that are big A, little a, and I have 1 that is little a, little a. Phenotypically, I've got 3 that are, they all have the dominant A, so they all exhibit the dangling ear or the unattached earlobes. So it's 3 unattached to 1. There's only one lone square that has 2 recessive alleles, which means they have to exhibit the attached earlobe because they have 2 recessive. They're homozygous recessive. So they would say 3 attached to 1 attached. If I go back and I actually look at this square, you're going to have 16. The ratio will still be the same. All right? I want you to look at that. look at these 16 squares and come up with a ratio for how many are big A, how many are big A, how many are little a, and see if it still fits a 1 to 2 to 1 ratio. It may not be 1 to 2 to 1, it will be something that is a multiplier of that. It may be 2 to 4 to 2, something like that, but since it's 16 squares, it's most likely going to be 4 to 8